Welcome to Chapter 11, where we are going to be learning about finding the area of polygons. We're going to talk about a lot of different shapes throughout this entire chapter. Today we're focusing on parallelograms, triangles, and circles. When we're finding the area of a shape, notice what we're actually finding. So this shape over here, we have these edges that make up this parallelogram. Note that the dotted lines are not included in the actual shape, but we are going to talk about them in a minute on why we need them. When we find the area, we're finding all of this shaded region, right? So that's what we're actually finding regardless of the shape that we're dealing with, okay? In order to find this area of that shaded region for a parallelogram, which again, based on what we learned in the past, includes rectangles, squares, and all other types of parallelograms. The formula to find this shaded region based on that type of shape is right there. Okay, A equals B times H, where A is the area, that's the shaded region we're talking about. B is the base, which over here, that is one of the sides of your shape. So we got the bases right here. And then the height, that's what the H stands for. The height is the vertical distance from the side that it's across from. Okay, that's why we have this over here, because if we extend these sides, this height creates a 90-degree angle with our base, right? So whether it's inside the parallelogram or outside the parallelogram, we want to know that distance from one side to the other, okay? One thing to note about the area is make sure that whenever you give the area, you always put it in units squared. That's how we measure the area of a shape, okay? So again, just a quick reminder, remember that the base and the height must be perpendicular or create a 90-degree angle to each other. The reason we point this out is one common mistake is students will use this as the base, and then they will mark this other side, the side next to it, as the height. Well, if you notice, it does not create a 90-degree angle, so we're not allowed to do that. Be careful with that. So we got our base and height, where again, the base is one of the sides and the height is the distance from the opposite side to your base. Okay? We're going to go ahead and apply these formulas on these two examples here. So if we look at example 1, again, it's a parallelogram. They would tell us it's a parallelogram. So we're going to go ahead and use the parallelogram formula. Area equals base times height. We just need to be able to actually label our values. A, we don't know, because again, area, we're finding this shaded region. That's what we're doing. Now notice they give us 3 values, okay? The base is going to be one of the sides. How do we know to pick this side instead of this side? Well, if you look at our diagram, remember that the height is the distance from the opposite side, creating a 90-degree angle. So I cannot pick this 10 because there's no distance giving me that 90-degree angle. So this 10 is really not necessary for what we're trying to find. The base is going to be the 19 because that's the side that we're talking about. We're going to plug that in for B. And then the 8 is going to be that height because, again, it's the distance from that opposite side to our base. Once we have those numbers, we're going to plug them in and go ahead and use our calculator to find the total area. So we have 19 times 8, and we're going to go ahead and get 152. Don't forget, we said it before, our units are centimeters, but because we found the area, it's going to be centimeters squared. Taking a look at example 2, notice that we have those 3 90-degree angles, which means that fourth one is also a 90-degree angle. So we have a rectangle here, okay? Because it's a rectangle, we don't really need that vertical distance inside it or outside it, because we know that because it's a 90-degree angle on the corner, that this is that 90-degree angle we're talking about. The base is the one side, and then the height would be that other side that creates the 90-degree angle. It just so happens that for rectangles and squares, because they meet at a 90-degree angle, that is the direct height. So again, using the formula, area equals base times height. plug in what you know, which is the base of 11.8 and the height of 3.2. Use your calculator, and we end up with 37.76. So the area equals 37.76. In this case, notice it's inches though, so we're going to do inches squared. Make sure you're not doing centimeters squared anymore. Make sure you have the correct units. So that's how you find the area of a parallelogram, whether it's a square, whether it's a rectangle, or any other type of parallelogram where they do not meet at 90 degrees. Let's take a look at another shape and finding the area. So for this one, we're going to find the area of a triangle. Okay. Again, the area is this shaded region that is all inside those boundaries created by the sides. The formula for the area of a triangle is a little bit different. You have two options here. You have area equals 1/2 base times height, or area equals base times height over 2. They're the same thing. They're just written differently. Just like before, B is going to be our base. H is going to be our height. A is the actual area of the shape, that shaded region. So looking at our diagram over here, again, the base is going to be one of the sides of the triangles, but you have to make sure that that base creates a 90-degree angle with your height. So I'm going to put it in blue here. If you choose this side, that's fine, but you need to make sure that the height to the opposite angle creates a 90 degrees. So then you get really complicated out there where the height has to be on the outside of the triangle. So before you start, you're better off just looking at the shape and see if they give you that 90-degree angle to identify the base. So here we have the base, and here we have the height. And again, triangles are almost more complicated than rectangles, are more tricky because a lot of students will want to use this other side as the height. But again, they do not meet at a 90-degree angle, so make sure that you do not do that. Okay. So we just mentioned that. Make sure the base and the height must be perpendicular, which again meet at a 90-degree angle to each other. And just like before, you're always in units squared. No matter what the shape is, whether it's a parallelogram, a triangle, we're going to talk about other shapes, your area will always be in units squared. So looking at our two examples for this, if we notice for example 3, the base this time is going to be up top because it creates that 90-degree angle with this given length. So we have the height here, which is the 90-degree angles created with the base here. So now let's go ahead and use our formula. Now I personally would recommend this one. I think it's easier to use. I think it's less likely for you to make a mistake. But again, you can use either. We're going to show you both right now. So area equals base times height over 2. Just like before, plug in the values that you know. We have 14 times 3, all divided by 2. I would do the numerator first, just to be safe. 14 times 3. So our numerator is 42 divided by 2. And then you can go ahead and do that again and do 42 divided by 2. And you'll end up with 21. So our area for this is 21. Don't forget it's in inches, so it's going to be inches squared. If you were to choose the other formula, 1/2 base times height, because 1/2 as a decimal is 0.5, I would recommend typing in 0.5 times those values you're talking about. In this case, 14 times 3. So the area is 4.5 times 14 times 3. You end up with, again, 21 inches squared. So notice they're the same. They will always be the same because they're the same formula, so you don't have to do both. You just have to do one or the other. I just wanted to take the first example to show you both ways of typing it in. Which again, area, because it's inches squared, let's go ahead and shade that region. That's what we're finding. For example 4, kind of like the rectangle example, right, where there's no dotted line showing us that height. That's because one of our corners actually meets at a 90-degree angle. So we're going to make this the base, and that other side that it meets with, we're going to go ahead and make the height. So kind of like the parallelogram example, we don't need this third side for what we're trying to do. Okay, last chapter, 2 chapters ago, if we were trying to ask if it's a right triangle, you would have to use that. But in this case, we don't necessarily have to. Okay, so area equals base times height over 2. Base is going to be 15. Height is going to be 8 all over 2. Let's type in our numerator, which is 15 times 8. You get 120. Then go ahead and divide it by 2, and you're going to get 60. So we have 60 millimeters squared. Don't forget the squared. That is the area of our triangle. So at this point, we've talked about finding the area of parallelograms, and we've talked about finding the area of triangles. You have the formula and the process for doing both. The last shape we're talking about today is finding the area of circles. Now, you guys just spent the whole last chapter finding a bunch of things about circles, right? Labeling the radius, diameter, arc measure, arc length, tangent lines, all that fun stuff. Now we're actually going to find the area of circles. So we decided to wait to do the area of circles until we did the area chapter. So here's your formula. Area is the A value. Notice that you have a pi symbol. Pi is just a number. It's an irrational number, so it's going to be roughly 3.14. But don't look for any values to do. R, as we learned the last chapter, is the radius. Remember, the definition of a radius is the distance from a center point to the edge of the circle. So R is right there. Notice, we're going to point this out, that the diameter, again, is from one edge of the circle to the other edge through the radius. So if you have the diameter, right, diameter is that length, distance from here to here is also radius, so 2 radii equals the total diameter. So if you're given the diameter, I'm pointing this out because we're going to have an example where they give us the diameter, all we have to do is divide by 2 to get the radius. The reason I'm pointing this out is notice our formula has radius, not diameter. So it's important that you must use the radius in order to find the area of the circle, not the diameter. For example 5, they give us the radius because, again, distance from the center to the edge. So this is R. Go ahead and use our formula. Area equals pi r squared. Plug in what we know. Pi times 5 squared. 5 squared is going to be 25. So the area of this circle is 25 pi centimeters squared. But we want to give this approximation because 25 pi, how much is that? We don't really know. So we're going to go ahead and plug this into our calculator. So I'm going to show you where that pi symbol is. So we got 25, and then if you want to find the pi symbol, look here. We got a blue little pi thingy right there. Okay, so you're going to hit the blue button second, and then that button, and you can go ahead and get the pi symbol there. So 25 pi, hit enter. Now we have the actual approximation of 78.54. So the actual area is 78.54 centimeters squared, which again is this shaded region. If I shade in this whole circle, that is all the space that we just found. The total area, 78.54 centimeters squared. The last one we're going to do, notice they're giving you the full distance of the radius. So like we talked about up top, the full distance of the diameter. Remember, like we talked about up top, the radius is half that length. So if the diameter is 16, the radius would be 16 divided by 2, which is just 8. So you can't use the formula until you have the radius. So the area would be pi times 8 squared. Again, not using the diameter. So area is 8 squared is 64. So the area is 64 pi inches squared. But we always want to try to find that approximation value if we can. We're going to go ahead and type this in. 64 second caret pi. Type that in, you get 201.06. In this case, we're still in inches squared. So the total shaded region here, again, is 201.06 inches squared. And that's how you find the area of a circle. So now that you have the formulas for those three types of shapes, right? The parallelogram, the triangle, and the circle, we can solve for any areas of those shapes. So here are our three-step foolproof problem to finding the area of a shape. Step one, write the formula. You have three different formulas. You got to make sure you write the one that goes with the shape you're working with. Step two, sub in the values like we did. Remember, it's got to be the actual height, not the slant height, and it's got to be the radius, not the diameter. After you do that, type it in, get your answer, and then just make sure you answer with units squared. Okay? Follow these steps, and you guys are going to be awesome.